Yes, welcome back. So, right. So mostly we connect our access is the devices that we access are routers and then wireless access points. We don't go and, for example, you would like to perform a network connection from your switch to your laptop through a wire. I don't think nowadays laptops also coming up with Ethernet ports. They are coming up with they don't have Ethernet ports basically. So few years ago, when there is no Ethernet port, when I see that there was no Ethernet port to a MacBook, then I was surprised. My God, no Ethernet port, as if that is the most important thing. I like that. I think our mind was thinking that Ethernet port is very important. Otherwise, uh, if Wi-Fi is not working, something goes wrong. How can we connect? And how many times you just pull the cable and connect it to your laptop directly. Network cable happens. So uh, mostly we connect only to routers and then wireless access or wireless access points. We don't directly go and connect Ethernet to the Ethernet ports. If you connect your computer to the Ethernet port, then there is only one-to-one relationship. Then you can have one Ethernet port is directly connected to a computer. Then your computer and internet network access card, which has got, even your computer has a MAC address which has got a network access card. Then the communication is only 10. How many devices if you really connect it? These many devices can be connected, but if you extend the network, if you want to form the no switch is a pretty big thing actually. Maintaining a switch is not a simple thing in networking. But how they are connected as wireless access networks, or it's extended, how the network is extended. Everything is based on routers and routing tables, how the router forms the routing table, how the router routes the data based on a routing table, and etc. concepts. So the next concept is very essential. So I don't know, this could have been the second. What do you know about IP address? That's my first question. What do you know about IP address? So, no, just to tell me, what do you know about an IP address with the experience you have? So,
Uh,
yeah, please.
it's address assigned to a device by which we could be able to check in that number and connect to it.
Yeah, that's fine. It's what you said is true. It's a address basically. So based on that address, it's something like a house number or something. Based on the address, how you can a postal department can send a letter to the house. Based on the street, how they can send the letter to first to the street. Based on the pin code, first how they can send a letter to your post office. From there they search for the street, or they can distribute it to different post offices from if it is a city, and then from different post offices different postmans will come and dispatch the letter. So that is how different layers are. Ultimately the house number is which is very important, where it has to send the letter to. Right. IP is a protocol. It's a packet forwarding protocol. That's the reason we call it as TCP/IP. The pair of two protocols, we bring it as one concept, which we call it as TCP/IP UDP. Actually UDP/IP, but we don't say UDP/IP. We always use it as UDP. HTTP, and HTTP also requires something IP address, but we directly call it as HTTP. But TCP IP is very famous combination, and then the name is set up like that, which is called layer 3 plus layer 4, ultimately TCP IP. So IP is a forwarding protocol, and each and every connected device in a network, it should have an IP address. It should have an IP address to identify itself. So you know that it's set of numbers, like something like IP, and then there are two variations which are called IPv4 and IPv6. Uh, if there is no software defined networking, by now we would be talking more about uh, IPs as in IP6 format, which is very hard to digest. Our mental model is IPE means directly it goes to 198 dot that format, but actually there is IPv6. It's going on. Even I think China, I heard that China has so many devices and then they want to go directly with IPv6 or something. Some project is going on. However, IP is that
Uh,
protocol.
can
Yes.
I ask a question, sir?
Yes, please.
For example, we earlier worked with the Modbus TCP/IP communication protocol and all. So you told that the IP address is formed when a network is connected, but it's like like our controllers, the PLC or the other data logger controllers. When you connect to with an Ethernet cable to the laptop, and then it is asking us to enter an IP address of the device. So even if that device is not connected to the network, we are still getting an IP. Correct, sir. So in that case, is it something which is given permanently to that device?
No, no IP address is permanent. IP addresses are always floating. No IP addresses, nowhere actually. The IP addresses are permanent. IP addresses are not permanent, unlike MAC
So
addresses.
like our C sharp, you remember, no, like what is a connect by Modbus TCP IP. So we are entering 192.168.1.12 of that particular controller. Then it is getting connected to that particular
Because
device.
192.168.0. I think whatever the series, whatever the numbers we have connected, because that particular device, the Modbus or something, the device is already connected to your router. Okay, that is the device is connected to your router. So as soon as it is connected to the router, you get an IP address. Even though you don't connect to the router, also you can get the IP address. But there is, if there is no network, there is no need of having an IP address. You built a house inside a sea on a ship. Then there is no need of address as well, because no one can communicate to you what is the need of an address. Okay, your house is inside a boat inside mid of the sea, then no one can communicate to you. It makes sense to have an IP address or the address if there are rows of houses are there inside a colony or inside a village or a street or a city, whatever. But the house is there inside the sea, then there is no need of an address at all. Even you can put an address for yourself. Okay. Otherwise, you have to form your own network, like what is that? Nityananda Swami. He has to form your own network by bringing up one own island, and then you issue house numbers, and then you form the network. So there he's the king. So he calls himself as a king. So he forms the network. He has got all the authority. So all the house numbers and all he can control. But if Nityananda is staying something alone in his own house, inside the mid of the sea, on a boat or on a ship or whatever it is, then you cannot establish communication to the outside world. Then there is no meaning of even having an IP address or postal code or whatever it is. So you can have IP address. There is no problem at all. You can have your IP address, but if there is no communication to the external device, there is no need of IP address. That's what I mean to say. So yeah, in general, IP addresses are not permanent, at least so far the network we know. uh, yeah, uh, that's what. Even actually IP addresses are not permanent, MAC addresses are permanent. The devices that are really working on the physical devices, that's where the MAC address is permanent. The IP addresses are just a layer is formed for the uh, so MAC addresses are your permanent houses, IP addresses are your
Sir,
rented houses. Yes.
sir, if MAC address is permanent, why can't we ping to that MAC address and get the data?
Why can't we ping to that particular MAC address and get the data? So we have a MAC.
Because
I'll
yeah,
tell you. Now we have a MAC address. So you have a MAC address. For example, you have a MAC address. Now I would like to ping you. You have a MAC address, right? So
okay.
if I want to connect you to your MAC address, there are billions and billions of MAC addresses in the internet. There are billions and billions of MAC addresses. Okay, there are billions and billions and billions and trillions of MAC addresses nowadays. Even Java applications also see that 4 billion, 5 billion, 10 billion downloads are there. You can understand, look at the scale of the devices that we have. So a device, any device that has got network interface card contains a MAC address. It could be a switch, it could be a router, access point, wireless access point, or your mobile, your laptop, whichever has got a network interface card. I still remember network interface cards are even sold externally, so that we used to buy and then connect to our laptops. Internet card that we used to think internet card and go and buy, and then we can have a dial-up connection. If you have you anybody of you are remember about dial-up connection? Dial-up connection is there is a direct communication from your internet or service provider to your laptop. So IP addresses are, as I said about, it forms a network. Actually, IP addresses form a network. Just assume that all the students in the world are studying in a same school. All the students in the world are studying in a same school. How difficult to manage? I'm talking about very large scale, and it is not a practical example, it is just a fictional example. All the students in the world are studying in a school. So I want to call Naveen, I want to call Jitin, I want to call Sangam, Pawan. Even in my own phone there are 8 9 Pawan numbers are there. So specifically I put Pawan Reddy Dubai because there are at least 10 Pawans are there in my phone. One guy is Pawan Temple, one guy is Pawan working somewhere, one guy is Pawan Aruba Networks, one guy is Pawan VMware. Like that, there are 10 15 Pawans. Such a it's very common name in Andhra Pradesh. Pawan Srinivas is still, I remember whenever I'm sitting there near to my home when I was the teenager. Simply, I used to call, "Hey Subbarao," like that if the bus is going, because I am very sure that there should be one Subbarao in the bus. Then he will peep from look outside and see, "Hey, did you call me?" Like that. I did many times actually. Chumma, I just call, "Hey Subbarao, hey Subbarao, hey Srinivas," like that. So, because that is the gut feeling that in a bus there is definitely one Subbarao, one Srinivas, one Samashivarao, one Venkateswarlu, like that. Maybe the later stage, it is little advanced name. The next generation is Suresh, Mahesh, okay, and Pawan, like that. The Krishna. These are all the names generally we have actually. So assume that the scale, just giving you some example so that your mental model can understand what the difficulty. So if all the students are studying, everyone is different, like MAC address, all of them are studying in the same school, how do you identify them? Definitely they need to have some routing mechanism. Even there are 10 Pawans are there, 10 Navins are there, and 10 Jitins are there. Even to call them, you need to specifically say something. The routing, that's what here, the matter is routing. Understand, the routing is, simple thing is, how do you identify, when a letter comes to a school on the name of Jitin, for example, there are 10, 15 Jitins are there in the, if I'm a Keralite, definitely Jitin or Jite should be there, more widely used name. So that comes to the school, letter comes to the school, how difficult it is to deliver the letter. So you need to route. Okay, it's Jitin. He's studying in 10th standard. He's from the second B section. Uh, Give this letter to him, like that. If you give to the attender, definitely he can go and give the letter to him. But how difficult it is, there are millions of students are standing there and then keep on going and asking, hey, are you Jitin? No. Are you Jitin? No. Are you Jitin? You have to go and ask each and every million. I'm talking about, if all the students in the world are studying in the same school, you cannot definitely go and ask each, and that is the problem with MAC addresses. You can establish communication with MAC addresses, but there is no routing facility. MAC addresses are just to identify, just to give the uniqueness, because somewhere that you need to have that uniqueness. Somewhere that you are talking about Jitin, there should be some guy, he has got a curly hair, he's from this, he's from that. Some other Jitin who has got bald head, he looks thin, he looks short, or something like that. There are some uniqueness, maybe, but the uniqueness is not definitely, there is Jitin. How does it look like? You cannot go and say that he has got two eyes, two ears, one nose, and then one mouth. Then he has got a hair, and he wears pant and shirt, has two hands and two legs. You cannot. That is not called uniqueness. Uniqueness is, unique is, you should able to identify exactly that one. That is called the uniqueness. That's what even pointers in the memory. Uniqueness. You should, so that uniqueness is there for MAC address, but to reach that, to identify that uniqueness, as I said earlier, you cannot go even in a school. How do you think about billions and billions of students are studying in the same school? You cannot. So you need to have the better mechanism to form a network. So different schools are placed, which are called different networks. Okay, they are all connected by the switch as called different classrooms. They are all have routed with IP addresses or something. They are all have different sections, and inside every section there are different students. So it is very easy to route them. But as per, that's the difference. I hope you understand this difference.
Yes, sir. Yes, now I'm getting it, because it's possible, but it is very difficult to, probably if we scan and get the data, it may take 10 days to get connected,
I
something like
don't
that.
think even 10 days, some years it
Oh,
takes with the
oh,
scale of network we have right now.
oh, okay.
I'm
Good, sir.
talking
Thank you.
about just one connection. Okay, we in our own machine, in our own computer, if you really open a Wireshark or some other network packet capturing device, you understand really how many networks you are connecting. I will explain Wireshark as well in this concept, because you need to know if there is a problem with the network. Definitely you need to have some troubleshooting techniques that are, Wireshark is one among them. So yeah, so IP addresses are again two types of IP addresses: IPv4 and IPv6. IPv4 means what generally we use, which is called 32-bit numbers. uh, that means 4 bytes. 32-bit is nothing but 4 bytes. And for brevity, for easy to understand, each byte is separated by a dot symbol, and then you know that the basic thing byte is nothing but 8 bits, and then each bit can have two variations, on and off. When you look for electronic signals, high voltage and low voltage, 0 and 1, or 1 and 0, whatever. So the each and every bit can have either 0 or 1. So altogether one byte can form 0 to 255. If you are aware of ASCII code characters, there are 255 ASCII code characters, 256 ASCII code characters from 0 to 255. The numbers are, and uh, that is how you can identify characters in at least earlier computers. Okay, before the latest standards came. So each bit can hold, each byte can hold 20 to 256 characters, 256 numbers from 0 to 255. So there are 4 bytes like that, and then you understand what is the how many addresses are formed, you know. Just to have some simple thing, there is a story actually. Nowadays what I'm doing is, most of the times I like to listen to old Telugu stories. Most of the time, whenever I'm not doing in the technology, uh, before going to sleep and all, I don't watch anything. I just keep on listening stories. That gives a lot of soothing feeling to me. uh, Lot of fictional stories, and then some Tenali Ramakrishna stories or different stories. Recently, I heard one story, and there is a king, and he's very much fascinated about chess game. He likes chess game, and he feels that no one can beat him in chess game. And he announces that anyone can win on him in chess, then he can give him whatever he wants. Then many people tries, and then they fail. So I don't know. Kings, even for silly things, kings say that if you are failed, then your head will be chopped off and uh, uh, tied to the entrance door of your kingdom. Or I don't know all those things, but every story it has got like that. King always gives some praise as well as some punishment as well. If you win, you know, a lot of if else cases are there with kings. If you win, you get some praise. You get a queen, you get half of my kingdom, or you get so many gold coins. If you lose, you know, your head would be chopped off. Those are the general stories. So he is so much proud of something like that. He knows chess game. Then one intelligent guy comes. Then then he says that, yeah, I would like to play a game with you. Then he's so intelligent that he's nothing but the okay, whatever it is. He wins on king basically. King is surprised. Oh my God, he's such a wonderful person. And then the other guy tells that king asks them, you know, what do you want? Then he wants that on the chessboard there is, I think, 64. I'm not pretty good at chess. 18 to 8. There are 64 blocks are there. Uh, for each block, I want you need to double the rice. That one rice piece. Let us say on the first he needs one rice. On the second, double of 1 is 2. On the third, it is double of 2 is 4. On the fourth, double of 4 is 16. Then king himself feels he is very intelligent, but somehow he lost on this guy. So he said, okay, not a problem. Then at last they calculate that the whole kingdom's rice also, if you give to that particular guy, still he has to give some more rise to him, because the double, the power of is very very powerful actually. It looks 2 power 10 or 2 power 64, 2 power 32 looks pretty simple actually, but when you really look at the number, it's a OMG number. Oh my god. Then the guy tells that I just want to kill your ego, and then your what do you say, you yourself feels that you are an intelligent person. I'm the son of this the minister. Actually, I just would like you to know that there are so many intelligent people in the world. It's not like you are only intelligent, and then don't keep that in your head. Or something. He gives a lesson indirectly. Definitely, he cannot say that to the king, but indirectly he convey that particular message to the king. So you understand the scale. This story is pretty good example that even we realize that uh, you know how the power how the power power plays, we are talking about how the power to the power of 2 to the power of is very very powerful actually. It's very dangerous, you know so if someone comes and tells that can you give me something which is 2 to the power of 64, if you give that, then 2 power 64 is such a big number that even Bill Gates or somebody cannot give. Of course, Bill Gates is not that number one. Now, if we're talking about Elon Musk or some Jeff Bezos or somebody like that nowadays, in general, still, in our generation, we talk about still we are thinking that Bill Gates is number one. I think that's the reason we always talk about Bill Gates, but Bill Gates is not number one. So, this simple story tells that the power is pretty important, and then pretty powerful. So the IP addresses looks like four numbers, four 8-bit numbers. Uh, they look like actually okay, 255 256 0 to 255 dot 0 to 255 dot 0 to 255, and then dot 0 to 255, but actually they they form 3 4.3 billion IP addresses, 2 to the power of 32 actually. They form 4.3 billion IP addresses in the world. So, and even then 4.3 billion IP addresses, I'm talking about the direct addresses. I'm not talking about the addresses which we have got in our home. We are having, if you look at IP address routing table, if you look at IP address, you may get some number like 192.168. some 0 dot something. That is our private IP address. I am talking about public IP addresses are 4.3 billion IP addresses. Only IBM was having actually, I think, some million IP addresses, because they went and took control of initially, because it's a very old company. I think later on, I don't know whether they are distributed or what. That's the power of 2 to the power of. Really, I never thought of all these things when I was studying. When I was studying, my focus is always cricket, playing cricket, playing cricket, playing cricket. Even my mathematics notes are with scores. I hardly went to the college very, very few days, but I could have put all these efforts those days to understand the things. Right. So we are going out of IP addresses. So IPv6 came. IPv6 is 32 itself is 4.3. It is not the difference between 32 and then 128. It is the difference between 2 to the power of 32 to 2 to the power of 128. So when you go for IPv6 addresses, unless until we go out of our planet or even out of our solar system, at least go to this Milky Way galaxy, we are okay. As far as we are okay with this IPv6 public IP addresses. uh, I think at least not a Milky Way or something, at least our solar system. This entire solar system has got humankind or some intelligent civilization, and then people start using IP addresses. if, then that is IPv6 is enough, because it you can have 2000 addresses for per each inch on our planet by using IPv6. So understand the thinking of our innovative people from IPv4 to IPv6, the way how within few years, we hardly know internet from 2000. Maybe it might have started something in 2019, early 90s, and then within 20 years, uh, they might have not thought that 4.3 billion addresses will be used. At least the next time they understand that instead of going for 64-bit, they understand that they should go even further, because the advances that mankind has nowadays, it's actually every 10 years the technology is at least doubled, not doubled even, if you look at the last past century, the technology has took a turn in 2000s, and then from 10 years, it is really disruptive into the market. It really doubles, triples. So they understand that they need more IP addresses at least in the future. So rather than going for 64-bit, they went for 128-bit, I think so. So 2000 IP addresses you can put on each inch on the earth. That's what. And one of the things about, however, at least in our local networking, we don't use IPv6. We don't need to use, because we don't use 4.3 billion devices in your home. You don't use. There are no 4.3 billion devices, at least to your internet provider. So IPv4 is more than enough actually. But at a core level, IPv4 will not. It's over actually. It is like it reached a stage where it requires more IP address. But because of software-defined networking, somehow companies are maintaining that, which is called IPv6. Okay, and the second thing is subnet. Actually, this is very uh, wonderful concept. Before going to know the subnet, you need to know that what an IP address contains. Let us say 192.168.1 dot, for example 139. This is an IP address. When someone says this particular IP address, uh, what you cannot take out anything with this IP address. You know this is only an IP address. But if someone says that, first of all, you need to know that each and every IP address, it is divided into two parts. One is called network address, and the other one is called host address. That means a device address or whatever. Every IP address is not an IP address. It contains two parts. One is the network address and the other one is host address. For example, if I am in my home, my laptop currently is having this IP address, for example. Then if I connect another device to the router, it also contains 192.168.1 dot, maybe 140. So here what you need to do is, there is an network address and then there is a host address. So based on the network address only, your router, the physical router, or even if it is a software defined networking inside your machine, it understands that it has to route to the same network, or it has to route to the external network. There are levels of uh, uh, networking, right? First thing is whether it has to check whether it has to connect to the same network, and then it has to connect to the different network. How does it know is, there is a concept called subnet. Without subnet, without subnet, there is no meaning for IP address. So subnet is very very important in IP address. Now, if you say this, you may not take out, but if you say that 255.255.255.0, you can take out this. This is the network address and this is the device address. So here 192.168.168.1 is the network address, and 139 is the host address or a device address, and 140 is a host address or a device address. So whenever from your machine you call this address, it first checks that whether it is in the same network or not. How does it check whether it is in the same network or not? Is based on the network mask subnet. Subnet tells that whether it is in the same network or it is in that different network. There is a big calculation. It is not as simple as it looks like that. At a high level, I am telling, because to explain the same concept itself, it takes 2 to 3 hours. This is called subnetting. Subnetting tells whether the device is there in the same network or different network. Based on that, if it is in the same network, 139 to 140, both of them are in the same network in the to the from the router perspective, then it communicates. It will not. It has got only east-west communication because they are all in the same. So external communication happens. Let us say this has to connect to 10.15.75.82. Then it understands. First it checks based on the subnet mask. Okay, based on the subnet. Okay, it is not the same address, so it has to route outside, and then whatever happens is a different matter altogether. So without subnet, there is no meaning of IP address. Remember that. Okay, that's one thing. I hope you are following me. Any questions?
Within it's a basically it's a subnet is nothing but a range, right? So there we used to have this many.
Yes, actually, subnet mask is something. Subnet is something. Both work internally, but yes, subnet tells that uh, subnet is not a IP address. By the way, you might have it looks like an IP address, but this is not an IP address. Remember that. Jiten Palaparthi is a person, but Palaparthi is not a person. You understand? You understand the difference. Jiten Palaparthi is a person, Karthik Palaparthi is a person, Adya Palaparthi is a person, but just Palaparthi is not a person, at least from Andhra's namings. Palaparthi is not a person, Palaparthi is a network. Jiten is a person. Similarly, subnet subnet IP address is not actually an IP address. It looks like IP address, but it is not an IP address. It tells, as you said rightly, yes, it is used to form a network basically. Subnetwork basically. Subnet is subnetwork. It is used to form a network because the network with 255 255 dot 0.0 is different than 255 dot 255 dot 255 dot 0. Though the numbers looks easy to see but complicated to computate. And then uh, yeah, you got it right, Pawan, somewhat.
Yeah,
Yeah.
I think it's basically generally the companies they used to have this dynamic IP address. No, that time they used
Yes.
to have this range used to define, and whenever you connect to the corresponding profile, so the IP address will be generated from this subnet, right? That the range is defined.
That from the subnet that tells that the network boundary. Subnet tells that network boundary, and then there is another concept called subnet masks. Actually, subnet mask, that there are some old two things are there about the subnet and subnet mask. I mean subnet mask and IP address classes. Actually, older versions IP addresses are formed based on the IP addresses are formed based on the what do you say, classes. Actually, class A, class B, class C, class D. But nowadays the concept is nobody is using that concept. We are using a concept called subnet mask. Actually, P editor. So just it's a routing table. So if you look at this, this is called masking. Actually, this is called subnet masking. So what happens is subnet. This is not an IP address. Basically, whatever I was talking about subnet, it's not an IP address. It is only a boundary. This is only a boundary. This is not an IP address. Okay. This tells that first, with when the subnet mask is there, this tells that first three are network address and the last one is an IP address. So last digit, last bit, even the last bit also you can split it. Actually, that's a different thing that we will discuss about it. This tells that 3 bytes belongs to the network address and the last byte belongs to the device address. So when you go to the other notation, actually nowadays this notation has become very popular. Where is it? Yeah, this is notation 192.1. I did lot of, I have changed my network like anything. That's the reason you could see a lot of things. I keep on doing some experiments on my network. That's why you could see that 19 this one will see 192.168.0.0/24. This is the IP masking rule. These are the IP addresses that are given by my wireless router. The interface is called wireless here. The other all internal software defined interfaces, but this is called the router, the wireless connection. We will discuss about routers, how to configure router, how to create your own router, and how to bridge between different routers. That's a different story altogether. This one, if you take about this, this is a very good example I saw in the internet. That's what. So here we are telling that there is 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. So 24 bits are masked. That means 16 plus 8, how much? 24, right? Up to here the IP, the network address is 192.168.0, and from here these rest of the bytes out of 24, the rest of the bytes, that means these bytes can form an IP address. Masking, this is called 24 bytes are masked. Let us say I put it as 10. That means up to here the IP addresses are network address. From here onwards, this is the device address. So this 24, it gives only 255 addresses. 250 0 to 255, so it gives only 256 addresses. The 0 is different, 1 is a default gateway if you are connected to the Wi-Fi, and the last one is called broadcast address. So ultimately you get 49 addresses or something, exactly 48 or 255, right? So 0 to 256, remove 4, and about 252 addresses you can form with this network. But if we just change this to 16, then the number will be 65,000 actually, or even more on the same IP range. Remember that this is a CIDR notation, classless. What do you say? CIDR. What is there is a separate name for that. I used to say CIDR notation, which is called, however, that is called CIDR notation. CIDR notation, calculator notation examples. There is a very big thing. You cannot real very difficult for you to perform these operations on your uh, uh, by hand actually. Classless inter-domain routing, it is called classless inter-domain routing, which is called CIDR. If you go and see the subnet calculator, so what you need is ultimately you need to have an idea about how big your network is going to be. Generally, whenever as a developers uh, we create our network interface, we create our network, we give some number actually. That's a common tendency. We go and give 24, 16 as it is, but actually it is not like that. It's all based on the size of the network, the topology behind the network. So 192.168.0.0, when I said 32, it can form only the input long, it can form only, I think this 32, it doesn't form actually any IP addresses. It can give IP range is 1, IPs in range is only 1, because all the 32 bits you're using. Now if you change it to 31 bit, then you know that one bit is 0 or 1, so it can give you two IP addresses. CIBR range is 192.168.0.0, 192.168.0.1. If you change from 30, then it's all 2 to the power of, remember that each bit is 2, it all goes 2 to the power of. Then if you see that 30 is 4, 29 is 8. I told you that story about the king, and that for that purpose 28 is 8 IP addresses, 28 is 16, 27 is 32, 26 is 64, and so on. And then when you go and give 16, it makes 65,536 IP addresses when you give 16. That is the difference between even the 16 and 24. 24 can give you, I think, only 256. Yeah, 24 gives you 256 IP addresses. Again, in that 256, one IP address is a broadcast IP address, which is called 192.168.0.255, and then there is a default IP address which is called 0.0. And then if it is a gateway, then the gateway takes 192.160.0.1, goes to the gateway router IP address and stuff like that. So you will be having ultimately to use, I think, 253 IP addresses or 252 IP addresses. But when you go changing each and every bit, you can see that it is always doing 2 to the power of. So that's how these many billions of IP addresses this give. So the number is looks, this is called masking actually. So how many bits, as I showed earlier, we are not going into more details about that because it itself takes a lot of time, but I want you to know this is called subnet masking. Subnet mask is not an IP address again. It is used to mask the IP. Masking an IP is nothing but in this particular range, how many bits you would like to mask, so that based on that it generates those many IP addresses. Network engineers are well aware of this particular calculation, but we need to know this calculation to in order to know that how the IP addresses are. For example, you say 10.10.10.0, and then you give, for example, 1. These many, just with this particular range, these many IP addresses are formed. Two, two, 200 and 200 147 crore IP addresses just with this range, with this particular bit. So masking is very very important. So that is called IP address masking. Before masking, the concept is called classes: class A, class B, class T, class C, D, and all based on the classes. But the classes are not as convenient as masking, which is called CIDR notation. I just forgot about the classless domain. R means what? Something like that. CIDR notation. Okay, the CIDR notation is domain routing. Yeah, classless interdomain routing is called CIDR. So this CIDR notation is widely used everywhere. You see this notation. Whenever you see this notation, you must understand that any IP address you see, you must understand that there is a network address and then there is a host address. You should able to identify that, and then you should able to identify what is the range. Long back even I did some program to give all the list of the IP addresses based on a range. In my GitHub repository it is there. If you give this range, if you give the IP address and then CADR notation, it gives the list of IP addresses, and then you can, it gives the list of IP addresses and all. But I did string manipulation. Instead of that, I could have done the bitwise manipulation. That I didn't do. Bitwise operators I have to use and do the bitwise manipulation. But that time I did manual string manipulation. That's a wrong implementation. However, it gives the output ultimately. Right. So uh, that's what we can discuss more about DHCP and then other constructs in the network, ARP, DHCP, and all in the next session. I think we already exceeding the time. Uh, uh, that's it for today, folks. Any questions? Please feel free to ask.